Hi everyone! So instead of a calculator tutorial on this Wednesday, I thought it would be cool if we worked on another word problem dealing with rational expressions. I'm really excited about this one because I was talking about word problems with my brother on the phone. He's a pilot and he was like, oh, I deal with these sorts of calculations a lot in my job. So I wanted to share with you a calculation that he works on sometimes to double check that everything his computer is doing is correct. So we're going to work on a pilot-related word problem today. So to get started, my brother just got a job at a new airline called Breeze Airways. He actually did get a job there, so he's super excited. And then his first flight was from LAX to San Francisco. So from Los Angeles to San Francisco. But pilots usually have more than one leg on a trip. And so after he landed at San Francisco, he then headed to San Diego. And so just flying, his total flight time was 159 minutes. And then I looked online on Google Maps and I saw that a flight from LAX to SFO is usually 338 miles. And then to get to San Francisco to San Diego is 447 miles. Another thing my brother was mentioning was in the wintertime in California, the airstream is moving north. So flights going north in the wintertime get a little boost from the wind, whereas flights going south during the wintertime are kind of going against the wind. And he also said that wind speed in the winter is usually 90 knots. So we're going to figure out what is the speed of the airplane going on the first leg of the trip. So what is the speed of the airplane when it's going from Los Angeles to SFO? And the very first thing I want to do is address this 90 knots thing because I'm not a pilot. I don't deal with knots. So I think a more approachable unit of measurement should be miles per hour. So I looked it up online and 1 knot is 1.15 miles per hour. So doing a calculation probably similar to the calculations you do in science class, I'm just going to convert 90 knots to miles per hour. And so it just turns into the calculation 90 times 1.15, which is 103.5 miles per hour. So that's just a little side note I wanted to do before we get started. And I'm also going to calculate minutes to hours because I want everything to be in equal units. And just like the last problem we did where we were talking about rowing against a current and with a current, we're going to really focus on the equation distance equals speed times time. And looking at all of these questions, I can see, okay, well, I know the distances, and I also am going to be able to calculate the speeds by looking at the speed with the wind versus against the wind. So the only thing that I really don't have any clue about is the time of each specific flight. So that's what I want to solve for. I'm going to have time as distance over speed. Okay. And then I'm just going to let x equal the speed of the airplane. So on our last one, we had the x was the speed of the current, but this time I want it to be the speed of the airplane. So let x equal speed of airplane. And I'm talking about it's just natural speed if there was no wind. Cool. So I'm going to make a little chart that's just going to help me keep track of everything. So I've got my locations. I'm going to have my distances. I'm going to have my speeds. And then I'm going to have my time. So just kind of making sure that I can collect all the information that I need to. Okay, my first location is from LAX to SFO. And looking back at my word problem, I can see LAX to SFO is 338 miles. And just thinking about a map, Los Angeles to San Francisco is going north. So this is going to be the one that's going with the wind. So our airplane speed is going to be aided by a 103.5 mile per hour wind, which is going to be super helpful. And now I can solve for my time because I have my distance and I have my speed. So I'm just going to make a fraction with these two pieces. We'll have 338 over x plus 103.5. And now we'll do the exact same thing with the other leg. So we're going to go from SFO to San Diego. And looking back at my situation, SFO to San Diego is 447 miles. And if you're in San Francisco going to San Diego, you're going south. So you're going against the wind. So we're going to be having our airplane speed hurt by a 103.5 mile per hour wind. And then we'll just make our fraction all over again, using that distance over speed idea. Okay. But then we have one more crucial piece of information. We've got our whole flight time. The only other piece of information I've really got here is my flight time for both parts of the trip, which is 159 minutes. But we've been dealing with miles per hour, so I'm going to switch 159 minutes to hours. And remember, there's 60 minutes in an hour. So this just becomes 159 over 60, which is 2.65 hours. So I also know together that the time is 2.65. And that is really all we need, because if you look at this column now, we have all the pieces of information we could need to make an equation with x in it. So I know that my LAX to SFO trip was 338 over x plus 103.5. And I know my SFO to San Diego was 447 over x minus 103.5. And I know that those two together took 2.65 hours. So now that we've kind of looked through all of that information, we can finally start dealing with this like a normal addition problem. So goal 1 is to find the LCM of both denominators, and I just need to have both pieces of the denominator included. So x plus 103.5 and x minus 103.5. Those need to be the two components in my dream denominator. And once I do that, it's just going to turn into multiplying to get this dream denominator for each part. So 338 over x plus 103.5. I need to multiply that by my second piece, the x minus 103.5. Same thing for the second one. We'll have 447 over x minus 103.5. And I'm going to use method 1 we talked about in class. Oops, sorry. Got to multiply by x plus 103.5 over x plus 103.5. Okay, I'm going to use method 1 that we talked about in class, where I'm just going to look at the left side and then cross multiply. If you like method 2, obviously you can use method 2, but I'm just going to use method 1. So when I multiply this numerator out, I'm going to end up with 338x minus 103.5 times 338, which is 3, 4, 9, 8, 3. Then I'll do the same thing with the second part. 447 times x is 447x, and 447 times 103.5 is 46,264.5. And then I've still got my denominator of x plus 103.5 times x minus 103.5. Okay, now I can kind of combine some of these pieces. So 338 plus 447 will give me 785x. Negative 34,983 plus 46,264.5 gives me positive 11,281.5. Still got my same denominator. And then we've still got that same right side of the fraction that we haven't dealt with. But I'm going to rewrite this as a fraction, because 2.65 over 1 is the same as 2.65. And then using method 1, remember, we can cross multiply here. So I'm going to cross multiply. This numerator times this denominator is just that times 1. So we're going to end up with 785x plus 11281.5. 2.65 times this whole piece. Well, first we could do a side step where we could multiply this out, and you'll end up with x squared minus 103.5 times 103.5. So we'll have 2.65 x squared minus 2.65 times 103.5 squared, which is 28,387.46. If you need to do those side steps, please do them, but just for the sake of time, I'm going to skip them. Okay. And then I'm seeing that this is turning into a quadratic. So I'm going to move everything so that it looks like a nice coherent quadratic. So I'll have 2.65 x squared. I'll move the 785x over, so I'll have minus 785x. And then I've got this negative number, and I'm also going to subtract that value as well. So I'll end up with negative 39,668.96. And since I moved everything from this side, we're just left with 0. I obviously do not expect you to factor this, so we're going to use the love of our life, Desmos. And we're just going to plug in this equation into Desmos. I've already done it, but as you can see, when our graph hits 0, it hits 0 at negative 44, basically, if we round up, and 340.23 if we round up. So I'm going to write that out. X is either negative 44 or X is 340.23. But we're talking about the speed of an airplane, and speed can't be negative. So I know that this can't be my answer. So we're left with this 340.23. And we also have to remember that my question was asking, what speed is the airplane going on its first leg? So on my first leg, I need to figure out what x plus 103.5 is. So LAX to SFO was x plus 103.5, or 103.5. And so we're just going to substitute in our x. 340.23 plus 103.5 is going to give us, let's calculate it, 340.23 plus 103.5 gives you 443.73. So 443.73 miles per hour, which is a very reasonable speed for an airplane to be going. Okay. I know that was long, but these problems can kind of get pretty long and complicated, so I wanted to make sure you had a nice step-by-step from me personally to help you figure out how that all works. If you have questions about any of the steps I did, please, please, please let me know. We can work on this together in office hours. But if you just need to pause the video, go back and look at some other pieces of the video, then you're good to go. Have a great day. Bye.